Okay, so welcome to section 5.1, which is verifying identities. So verifying identities. And let's recall our reciprocal identities and our Pythagorean identities. So the first reciprocal, cosecant of theta, of course. S's and C's go together, is a reciprocal of sine. The second reciprocal identity, secant of theta, S's and C's go together, is the reciprocal of cosine of theta. And then cotangent of theta is the reciprocal of tangent of theta. Our Pythagorean identities are, the main Pythagorean identity is cosine squared theta plus sine squared theta is equal to 1. If I divide each of these by cosine squared theta, I get 1 plus tangent squared theta is equal to secant squared theta. So tangents and secants always go together. However, if I were to divide the main Pythagorean identity by sine squared theta, I would get cotangent squared theta plus 1 is equal to cosecant squared theta. That is, cotangents and cosecants always go together. So let's note that sine is an odd function. So sine is odd, meaning it has 180-degree rotational symmetry. That also means that sine evaluated at negative theta is equivalent to negative sine of theta, as is its reciprocal function. So cosecant of negative theta will be negative cosecant of theta. We know that cosine is an even function, meaning it is a mirror image across the y-axis, so cosine is even. And what that means, pardon me, is that cosine of a negative angle, theta, is the same as cosine of positive theta. Similarly, for his reciprocal function secant. So secant of negative angle theta is the same as secant of positive theta. Okay, so let's consider, I'm going to plot both sine and cosine on the same set of coordinate axes. So let's consider theta versus f of theta coordinate axes. Let's see how much room I have here. Okay, horizontal theta, vertical will be f of theta. Okay, I have 1, 2, 3, 4 quadrants going forward and 1, 2, 3, 4 quadrants going back. I have an amplitude of 1. First quadrant is pi over 2. Sorry, the vertical is f of theta axis. Then pi, then 3 pi over 2, and then 2 pi. I have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Sine, let's plot sine of theta in blue. Sine starts at 0, goes up to amplitude, back down to 0, and is symmetric. It has 180-degree rotational symmetry. That looks something like so. Not drawn very well. Ouch. Okay, let's see. Okay, there's my estimate for the graph of sine of theta. And now let's go ahead and plot cosine of theta, which starts at amplitude and is a mirror image on either side of the y-axis and ends once again at amplitude. It looks something like so. Well, a bit shaky there. Okay, so this is an estimate to the graph of cosine of theta. Now notice that if I were to shift cosine to the right 1 quadrant, I would get sine. Okay, so I claim that cosine shifted to the right, so that's minus pi over 2. Remember, horizontal shifts are counterintuitive. That's equivalent to sine of theta. Okay, well, let's analyze this. So I have that sine of theta can be written as cosine of theta minus pi over 2. So what I'm going to do here is I'm going to factor out a negative. So, or first let me rewrite it as negative pi over 2 plus theta. And now I'll factor out a negative from the argument of cosine, because cosine is even, right? So if I factor out a negative, this becomes negative the quantity, pi over 2 minus theta, which, because cosine is even, is equivalent to cosine of pi over 2 minus theta, and that's because cosine even, right? Cosine is even. Okay, so let's recall. Pardon me. So for alpha plus beta equal to 90 degrees or pi over 2, this implies, let me write that a bit better. This implies alpha and beta are complementary, right? Complementary angles. Complementary angles. And that also implies that, so we have alpha plus beta is pi over 2. That means that beta can be thought of as pi over 2 minus alpha, or I could have alpha is pi over 2 minus beta. Either way, both are true. Okay, so what would sine of alpha be? Well, we know that cofunctions of complementary angles are equal, so I have that sine of alpha is the same as cosine of beta. But cosine of beta is the same as cosine of pi minus alpha, right? Because what did I say about beta? It's equivalent to pi minus alpha. Okay, that looks very familiar, like what I have above. Well, let's now do secant. Let me do a bit of a different color. So secant of alpha. Well, I claim that that's going to be cosecant of beta because cofunctions of complementary angles are equal. But what was beta? Beta, of course, was pi over 2 minus alpha. Did I put a beta up there? No wonder why I was confused. It's supposed to be an alpha. What am I saying? Don't listen to me. Alpha. Okay. And last but not least, tangent. I'll do tangent. So tangent of theta is equal to cotangent of beta, because cofunctions of complementary angles are equal. So this will be cotangent of, and let me get it right this time, beta is pi over 2 minus alpha. And let me define that in case I haven't. I'm not sure if I have or I haven't. So definition, what is a cofunction? The sets of cofunctions. So definition. Cofunctions, in effect, are pairs of trigonometric functions. Pairs of trigonometric functions. Metric functions, and I know that's not where I was supposed to hyphenate that. Whose name differs solely by co. Differs solely by co. That is, i.e., id est, we have sine and cosine are cofunctions. This is one set of cofunctions. The next set, of course, will be, what did I put up? Secant. And if I tack on a co to that, that would be cosecant. And finally, tangent, tacking on a co to that, and cotangent. So these are the three sets of cofunctions. And the theorem I wanted to show you, which is what is above, is that cofunctions of complementary angles are equal. So theorem, we did an activity with this, or a classwork actually, but this is just restating everything we did. So theorem, cofunctions of complementary angles, complementary are equal. Okay, that's exactly what I did up here. Sine of alpha is the same as cosine of beta. Alpha and beta are complementary. Sine and cosine are cofunctions, etc. Okay, so I think I will just post this as a first video in this section so that it's not so long.